So we want to know, what is the equation for momentum? When is momentum conserved? What is the impulse momentum theorem equation? And a 2,000 kilogram car experiences a 500 Newton force for 10 seconds. How much did its velocity change? So what is the equation for momentum? Well, P equals mass times velocity, and momentum is a vector. Mass is a scalar, velocity is a vector, so the direction of the momentum and velocity are the same. You're just taking the velocity and multiplying it by a mass. It's how much stuff is moving, how fast, and in what direction. That's what momentum is. When is momentum conserved? Well, P initial equals P final when no net outside force is exerted on the system. Am I still on screen? Barely. On the system, exerted on the system. Okay, so if you've got a car and there's no net force on the car, then the momentum is conserved. The car will move with constant velocity, constant direction, and so on forever. Now, if you have two objects, they can collide, that are part of your system. They can collide, right? Two objects can collide, but when they collide, bam, they apply equal and opposite forces to each other, so there's no net outside force acting on your system. Therefore, during a collision or an explosion, momentum is conserved. The only time you have momentum changing is if there's some kind of outside agent pushing or pulling on something in your system that's either adding or taking away momentum. Okay, what is the impulse momentum theorem equation? Well, force times time equals mass times the change in velocity. Force times time, which is measured in Newton's seconds, is called impulse. Mass times the change in velocity is a result of an impulse. The result of an impulse is a change in momentum. This is, oh, I really should have written delta P. That is, the impulse on an object results in the change in that object's momentum. And as long as the object is staying constant mass, which all the problems I'm going to give you, the mass is going to be constant, you therefore have a change in momentum. And we can use that for the fourth problem here. We've got a 2,000 kilogram car, so given you've got, here's a road or something, and you've got a car, okay, it's some kind of Lamborghini or whatever, and there's a force on it, an outside force acting. Usually it's the wheels spinning, friction, between the interaction of friction between the wheel and the ground, and it gives you a net force of 500 newtons. And delta T is 10 seconds. And what are we trying to find? Okay, we're trying, the mass here is 2,000 kilograms. And we want to know what is the change in velocity for the car. Okay, so to solve this, well, we use the impulse momentum theorem. Force times time is equal to mass times the change in velocity. Well, there's what I'm looking for. So change in velocity equals force over mass. That's really your acceleration, isn't it? Times your delta T. And now we have enough. Your change in velocity is going to be equal to 500 newtons divided by 2,000 kilograms times 10 seconds. Okay, so what is that? That's, 10 goes into there, 200, 500 divided by 200 is 5 divided by 2, 5 divided by 2 is 2.5, so it should be 2.5 meters per second. Does that make sense? Okay. Did I get that right? Okay. And so this will kind of be the, on the final exam, there's going to be a section on Unit 7, which was momentum. And these are the kinds of things I'm going to be asking, either a short answer essay or multiple choice or actually working problems. So there you go. Any questions? Just a little review of momentum, impulse momentum theorem, and conservation of momentum. Big ideas. That is all.